Let's look at the first type of vector multiplication, which is the scalar product. As we mentioned earlier, scalar product is always a dot sign to represent the multiplication. Okay, so let's go straight into an example. Let's say vector A here, it's 5 Newton and it's 45 degrees above positive x-axis, which we look at the previous video. It's the same example. Vector B is 3 meters and it's pointing towards the positive x direction, which is also as shown here. So if we want to multiply these two things together using scalar product, all we need to do first is to create an x and y axis, then place both the tail of the two vectors on the origin. So if you place them both at the origin, then it'll be like this. The tail of vector A placed at the origin, the tail of vector B placed at the origin. And since we know this is 45 degrees above positive x-axis, we know that the angle between them will be 45 degrees. Okay, now we will proceed with the scalar product. So a multiplication between a vector and a vector, what will be the result? Will it be a vector or will it be a scalar? Let's try and find it out. Okay, so let's find the magnitude of A dot B. So A is a vector, B is a vector, and I multiply them together using scalar product or dot product, therefore a dot. So we also have direction, but later we'll discuss whether there's a direction or not. So if you want to find the magnitude of A dot B, so what we do is we say, let's say A dot B, the answer of A dot B is a value called C. Okay, so in that case, how do we proceed with finding the magnitude is we break A dot B into AB cos theta. Okay, so here it might be a little bit confusing. Why is there a change of the way of writing? Why before this it's just a vector, but now the vector it's capsulated with a modular sign. Both A and B is capsulated with a modular sign. What does it mean? Okay, so if we have a modular sign and in there we put a certain vector, what will happen is we are finding the magnitude of vector A. Okay, that's the meaning of the modular sign. We are finding the magnitude of vector A. So in that case, if you find the magnitude of vector A, then that's 5 Newton. If we find the magnitude of vector B, that's 3 meter. And the theta here, according to the formula for scalar product, theta here is the angle between the two vectors, which if we see here, between A and B, the angle is 45 degrees. So once we have known that, we can substitute everything in. The magnitude of A, 5 Newton, magnitude of B, 3 meter, substituting the angle between the two vectors, which is 45 degrees, and we'll end up with our answer of 10.6 Newton. So that is how we determine the magnitude of a scalar product. Okay, but of course, we also, just now we mentioned that this modular sign is actually a way for us to say we want the magnitude of the vector only. But we also know that magnitude can be written as just A without the right arrow, right? So actually we can rewrite the equation like this as well. We can omit or we can remove the arrow sign on top of A and B and remove the modular sign. Then if you write this way, it's also correct as well. Because right here it's saying that I have vector A, I want to find the magnitude. This is the meaning of this symbol. But over here, if you write an A without a right arrow, straight away it means magnitude already. Okay, so this way of writing is also correct as well. So you can write like this, it's also correct. Okay, so that's for the magnitude of a scalar product. You know that A dot, if you see A dot B, break it down into AB cos theta. That's the formula. Okay, then direction for A dot B, it's no direction. Why? Because if you read here, it mentions scalar product. Why do we name it as scalar product? It's because the result of a scalar product is a scalar. So it means by the answer over here, the result of this product here is a scalar value. So there is no direction. The result of the product has no direction. So therefore, it's a scalar value or scalar quantity. Therefore, no direction. So remember, scalar product, the result of the product is a scalar, no direction. Okay, so that's a rough idea of scalar product. And in the next video, we'll talk about the idea of parallelness.